Good morning. So in today's lesson then we're going to have a look at interior angles in polygons. We're going to recognise the polygons and their features, and we're going to discover and find the interior angles of irregular and regular polygons. So as always then, it's best to check your prior knowledge first before you start this lesson. So you should know the angle properties of the different triangles listed there. You should know the angle properties of straight lines and points, so knowing that angles on a straight line add up to 180 degrees and angles around a point add up to 360 degrees. You should also know the total interior angles in a triangle and quadrilateral. So angles in a triangle add up to 180 degrees and in a quadrilateral they add up to 360. And you should know the definition of an interior and exterior angle, knowing that one interior and one exterior angle will add to 180 degrees as they produce a straight line. If you have any gaps in that knowledge, please make sure you go back and look at the previous lessons before you move on. Okay, so today then we're going to have a look at polygons. So a polygon, as it says there, is a two-dimensional shape where we have line segments enclosed in a region. And there are a large variety of these shapes. So we define them in two different types. We have regular polygons. A regular polygon is where all the sides are equal and all the angles are equal. And we have our irregular polygons, where all of the sides and angles can be different. And these come in a huge variety of shapes. So we have these ones here, which we call convex. Okay, so all of the sort of corners, the vertexes are pointing outwards. And we have this type, which we call concave, where some of those vertex are actually pointing sort of inwards. We need to make sure we know the names of the different types of polygons. So they're named depending on the number of sides that they have. So a three-sided shape we call a triangle. 4 sides, quadrilateral. 5 is a pentagon. 6 is a hexagon. You might be familiar with those ones already. Some of the others that we might come across though: 7 is a heptagon. 8 an octagon. 9 a nonagon, and 10 a decagon. We should know all of the names of those polygons up to 10-sided shapes. If you're not sure on those, please pause the video now and make a note of those different names. Okay, so we're going to have a look then at the interior angles in polygons today. So the interior angles, those angles that are on the inside. So we've got our triangle. Triangle is made up of 3 interior angles. We've got A, B and C. And we should already know the sum of the interior angles of a triangle is 180 degrees. For those of you who've not been in my lessons or seen my slides before, anything that's inside a green box is an important fact and might be worth writing down. So if we know the angles inside a triangle add to 180 degrees, can we work out the sum of the interior angles in a quadrilateral? Well, a quadrilateral can be split into 2 triangles. So if I draw a diagonal line across, I've now got 2 triangles. ABC is there, so ABC would add to 180 degrees. And we've got the green triangle, we'll call that DEF. And the angles in that triangle must also add to 180 degrees. So if I've got 2 triangles that add to 180 degrees, that gives us all of the different corners of our quadrilateral. If we add those together, then we get 360 degrees. So the angles in a quadrilateral add up to 360 degrees. Now we can use this method to help us to find the angles in any polygon. So we've seen that a quadrilateral can be divided into 2 triangles, giving us 360 degrees. A pentagon can be divided into 3 triangles. So when we're dividing into triangles, we start with one corner, one vertex, and draw our radiating lines from there to create these triangles. So what about a hexagon? How many triangles could we divide that into? There we are. We can divide a hexagon into 4 triangles. So once we realise we can divide these shapes into triangles, and we know the angles in a triangle add to 180 degrees, then we should be able to find the total interior angles of any of our polygons. So the rule then for finding these angles, the number of triangles a polygon can be divided into is always 2 less than the number of sides. So using a bit of algebra, if we call the number of sides n, then the number of triangles we can make is n minus 2. We know the sum of each of those triangles is 180. So our final formula then, the sum of the interior angles of an n-sided polygon is 180 times n minus 2. 180 degrees for each triangle times the number of sides minus 2, which is the number of triangles we can make. Okay, so again, might be worth writing that down. Now, if you're not great at remembering formulae, not to worry, because we can work them out as we go. So we've said then that a triangle is made up of one triangle, and one triangle has a total interior angles of 180 degrees. A quadrilateral can be made out of 2 triangles, so 2 times 180 is 360. A pentagon can be split into 3 triangles. 3 times 180 is 540 degrees. A hexagon can be split into 4 triangles. 4 times 180 is 720 degrees. So pause the video now, have a go at completing the rest of the polygons up to 10 sides. So work out how many triangles you can split the shape into and multiply that by 180 to get your total. So we should have then these values. So we've already done up to a hexagon. A heptagon, we can create 5 triangles, so 7 sides. 7 minus 2 is 5, and 5 times 180 is 900. And you can see there the results for the other shapes. Again, pause the video, make a note of those total interior angles or check your answers. So let's have a go at using those values then to help us to answer some questions. So here we've been given an irregular polygon. So irregular, all of the sides and angles are different. It's a concave polygon. It's got one angle that's pointing inwards, and we're asked to find the value of x. So our first step is to work out how many sides our shape has. So we've got 1, 2, 3, 4, 5, 6 sides. So a 6-sided shape. So if we apply our formula to our 6-sided shape, we've got 180 times 6 minus 2. Remember, the 6 minus 2, 6 sides minus 2 tells us how many triangles we can split the shape into, and that gives a total of 720 degrees. If we know that the entire shape contains 720 degrees, if we do 720 minus all of the other angles added together, we'll be able to find angle x. Now, just a reminder, if we see this shape in the corner, this small square, that tells us that that's a right angle, so that angle is 90 degrees. So they don't always label that with a number. Often you'll just see this small square in the corner to tell you it's 90 degrees. So if we add together all of the other angles, take that away from 720, so 720 minus 460, then angle x is 260 degrees. We can check our accuracy. We can see here that this is a reflex angle, and a reflex angle needs to be greater than 180 degrees. So always do a common sense check at the end just to make sure the angle you've got reflects the angle you're expecting. Okay, so 3 there for you to have a go at then, so please pause the video now and see if you can find the angles labelled with the letters. Make sure you count the number of sides of each shape carefully and work out the total angles first. Alright, so let's have a look at the answers for those then. Check yours, make sure you're happy before you move on. Alright, so now then that we've looked at irregular polygons, we're going to have a look at regular ones. So the difference then, regular polygons, all the sides are the same length and all the angles are equal. So if we can find the total angles in a regular polygon, then we should be able to find the size of each individual angle because they will all be exactly the same. Now you notice the only thing that's changed over here is our names. So for a three-sided shape then, a triangle, if all the sides are equal, we call it an equilateral triangle. Our quadrilateral, if all the sides are equal, becomes a square. And we've gained the word regular in front of all of the other shapes to tell us that those sides are the same. So when you're doing questions, look out for that word regular in front of the shape name to tell you that all the sides and angles are the same. So these were our total interior angles that we've already worked out earlier. To find a single interior angle then, we're simply dividing up the total interior angles by the number of sides or the number of angles that we have in that shape. So for our triangle, 180 divided by 3 is 60 degrees, so each corner of our equilateral triangle has 60 degrees. Our square, 360 divided by 4 is 90 degrees for each corner. The pentagon, 540 divided by 5 sides, 108 degrees. Our hexagon, 720 divided by 6 sides is 120, so each corner exactly the same size. Our heptagon, now our heptagon's a bit more difficult. It does give us a decimal answer, so rounded to one decimal place, 128.6 degrees. The octagon, 135. Nonagon, 140. And our decagon, 144. Now it is a good idea to try and memorise the total interior angles for a pentagon, a hexagon and octagon. They're the ones most commonly used in maths exams, so hopefully we already know our equilateral triangle and our square. So 3 more worth remembering as they come up the most often. So again, pause the video, make a note of those interior angles. Okay, so we're going to have a look at some exam questions then. So I'm going to do this by handwriting them just to make it easier for you to see. Okay, so we've got our question then. So this shape is made from a regular octagon and a regular pentagon. So we've got our 2 shapes there. We're asked to work out the size of angle A. So angle A on the outside here. So the way to work out the size of angle A is for me first to find the size of the angles inside my 2 shapes. Once I have those, I have the angles around a point, and we should know angles around a point add to 360 degrees. So let's start with the octagon then. So we know the formula for our octagon, 180 degrees multiplied by the number of sides, so an octagon has 8 sides, minus 2, that tells us the number of triangles we can make. That will give us the total value. So we can use our calculator to work that out. So we've got 180 multiplied by 8 minus 2, total interior angles of 1080 degrees. Now we want a single angle, so 1080 divided by the number of sides or the number of angles that we have, so we can divide that by 8, gives us 135 degrees. So I'm going to write that on to my diagram. Okay, we're then going to do the same for our pentagon. So 180. A pentagon has 5 sides, so 5 minus 2 to give us the number of triangles. So 180 times 5 minus 2 gives us 540 degrees. Again, we just want a single angle, so a regular shape we can divide by the number of sides. So divided by 5 gives us 108 degrees. So now we have those 2 angles. We know that angles around a point add to 360 degrees. So if we do 360, subtract the other 2 angles. Now you can either add them together first and subtract them, or just subtract them. So 360 minus 135 minus 108, and we get an answer of 117 degrees, and that's what we're going to put on our answer line. Okay, pause the video now, make sure you're happy with all of those calculations. You can see where they've come from. Okay, another example then for us to have a look at is this one here. Okay, so this time then we've been told we've got a regular hexagon and we've got two squares. Alright, we're asked to show that the triangle AHJ is equilateral. So to be able to show a triangle is equilateral, we know that an equilateral triangle, all the angles are 60 degrees. Okay, so again, let's start off then with the angles in our hexagon. So our hexagon has 6 sides, so 180, 6 minus 2. Let's use our calculator again, so 180 times 6 minus 2 is 720 degrees in total, and again we want to find just one angle. So 720 divided by 6 means we get 120 degrees. Okay, now we can go through the same process for our square, but we may already know from our properties of quadrilaterals that in the corner of a square each of those angles is 90 degrees. Angles around a point add to 360, so 360 minus the 120 and the two 90s will give us the angle in our triangle there. So 360 minus 120 and 90 and 90, again if you want you can add them together first, gives us 60 degrees. So we've found our first angle. We know that at least one of the angles in our triangle is 60 degrees. Now we also know that our squares must be the same length. So because our hexagon, all of its sides are identical, that means this square here and this one here have an identical length, and we also know from our properties of squares that all of the sides in a square must be of equal length. So if we know one side of a square, we know that the others are also equal in length. So that shows us that this triangle must be at least isosceles. I say at least isosceles because we know at least two of its sides are exactly the same length. Properties of an isosceles triangle are that if we know the top angle, then we can find the base angles. Base angles in an isosceles triangle are equal, so we can work out those. So our final bit of proof then, angles in a triangle add to 180 degrees. If we subtract the 60 degrees, we're left with 120 degrees. We need to share the 120 degrees equally between the base angles in our isosceles triangle, and 120 divided by 2 is 60 degrees. So therefore each of the angles at the base of our triangle is 60. Therefore all three angles are 60 degrees. If all three angles are 60 degrees, then the triangle must be equilateral. Okay, again, pause the video if you need to, check through the working, make sure you're happy with where all of those values came from and that you understand those different properties of our shapes. So now we have 3 questions for you to have a go at. So very similar to the ones we've just looked at. Pause the video, take your time, have a go at these. It is worth drawing out the diagrams to help you. Alright, let's look at the solutions for these ones then. So, our first one then up here, we've got our 360 degrees, 3 lots of 108 gives us 36 degrees. So identical pentagons, so the angle, interior angle in the pentagon is 108, so 3 lots of 108 subtracted from our angles around a point at 360 gives us 36 degrees. Our second one down here then, we've got our hexagon. So again, we find the interior angle in the hexagon, and we've got our square, which we know is 90 degrees at the corner, and angles around a point add to 360. So 360 minus the 120 degrees from our hexagon minus our 90 degrees gives us 150 degrees. This one up here then, we need to think a little bit more about. So the interior angles in a pentagon are consecutive. Consecutive meaning one number after another. So first step then, let's find the angles in our pentagon. So the total angles in our pentagon are 540. Divided by 5 means that if it were a regular pentagon, each of the angles would be 108. Now, we're saying we need consecutive whole numbers. So if we start with 108 in the middle, if I want to go up one number, I would have 109. So that's added 1. So I would need to subtract 1 as well to balance that out. If we do that and space them out evenly, then we get 106, 107, 108, 109, 110. And we were asked for the largest of those angles, and the largest is 110 degrees. So that's the end of the lesson then for today. Please click the link to move on to the next lesson when you're ready.